All right. So we are going to take some notes today on quadratics and also on systems of equations and how to solve them using our calculators apps. So to start, quadratic functions are polynomials where the highest power of x is 2. That means there's an x squared term. And the standard form for quadratics is this right here, ax squared plus bx plus c, where c is the y-intercept, or the point 0, c is the y-intercept. That is not the only form of quadratics. We have some other ones too. For example, we've got the form f of x equals a times x minus h squared plus k. And when we have that, that's vertex form. So the vertex is hk. And the other one we've got is a times x minus r times x minus s. This is factored form, and we have x-intercepts at r0 and s0. These forms, we don't really need to have them memorized because if there is ever a situation where we needed to know the key features, we could just graph and find them graphically. But sometimes it can be helpful to recognize the patterns of what the different key features do. Let's see if I can try to get this from stop adjusting constantly. Okay. We're going to do a problem that deals with the PolySmlt2 app, or if you're in Numworks, it'll be the equation solver. I'll go through both ways using both calculators. The kind of lead up will be the same. So commonly you'll get problems like this where you'll be given some data and eventually you'll be asked to build an equation. So for here, Otto is modeling the height of a falling object and collects the following data showing that the height h of the object in meters as a function of t, time in seconds. So we have some time and we have some height. Otto believes that a quadratic function with this format, h of t equals at squared plus bt plus c, where a, b, and c are constants, that just means numbers, would be the best to model the object. And we're supposed to show that a plus b plus c equals 32. This might kind of seem like it's coming out of nowhere, like where on earth does that come from? But what it comes from is taking this data point and substituting in to our function here. So if we input the value of 1, so if we do h of 1, that means anywhere we see t in our equation, we replace it with 1. So it'll turn into a times 1 squared plus b times 1 plus c, which doesn't have t in it, so we'll just leave it as c. And we know from here that the output of this equation is 32. So if we simplify, 1 squared times a, that's just a. B times 1, that's just b, and c is just still c. So we land with a plus b plus c equals 32. Again, it might seem like even that question, like why are we being asked that? The reason why we're being asked this is if we have an equation with 3 parameters, a, b, and c, that we're trying to figure out, if we have 3 equations that relate a, b, and c, we'll be able to solve a system of equations and find those values. So it's kind of guiding us into that by asking us to build some equations that relate a, b, and c. Write down 2 more equations for a, b, and c. We're going to use the other 2 points we have. So we're going to input the value of 3 and 5. So if we do h of 3, that would mean at squared, so a times 3 squared plus b times 3 plus c, and that would equal 37. So when we simplify that, we get 9a plus 3b plus c equals 37. That will be one of our equations. And then our next one will be what we get when we do h of 5, where we put in 5 for t. So it'll be a times 5 squared plus b times 5 plus c, and our output here is 29. So then we've got, this will equal 25a plus 5b plus c equals 29. And that will be our third equation. Solve this system of 3 equations to find the values of a, b, and c. So to do that, we are going to use the PolySmlt app in TI or equation solver in Numworks. The step-by-step instructions for this are right here, but I will go through them just step-by-step here. So to start, we're going to go to, we're going to press apps on our calculator. So I'm going to go to apps, and then we all have different numbers of apps just based on who had your calculator before. We're going to scroll until we can find the app that says PolySmlt2. So it's right there. I'm going to hit enter. Press any key to continue, it says, so I'll just press enter again. Then I'm going to go to simultaneous equation solver, and these settings should look the same for everyone. And I'm going to hit enter. We need to input how many equations and how many unknowns we have. So we have 1, 2, 3 equations, and a, b, and c, and 3 unknowns. So I'll put those in. We need to have the same number of equations and unknowns to be able to solve it. The rest of the settings we can just keep. Sometimes we might want to switch between fraction and decimal depending on the problem, but fraction keeps everything exact, so I'll keep it there. And then to hit next, I hit this button below it that says graph. I'm going to set up my 3 equations into something that looks like this. Basically what we have is a, b, c, and what it equals on the other side. Depending on your calculator, this might look a little different. I'll show what it looks like on a newer calculator in a moment. But for here, we're just going to rearrange what we have. So this will end up looking like this first one would turn into 1, 1, 1, 32. This one would turn into 9, 3, 1, 32, 37. And here we'd be at 25, 5, 1, 29. So that's what we would end up putting in these right here. So 1, 1, 1, 32, 9, 3, 1, 37, and 25, 5, 1, 29. And then we would just press solve, and it gets us our values. So x1 is really our a, so it'd be negative 13 over 8. B is 9, and C is 197 over 8. Having it as fractions keeps it so it is exact, because we're going to go on to use our equation down below. I'm going to show what it would look like in a newer calculator. So again, we start out the same way. So apps, this one just has the 2, PolySmlt, simultaneous equation solver. We have 3 equations and 3 unknowns. And I'll hit next. This one, same idea, but it just says X, Y, and Z. So we'll put in 1, 1, 1, 32, 9, 3, 1, 37, and 25, 5, 1, and 29. And we'll solve. And again, we get the same thing that we got. Last but not least, Numworks, your instructions are a little different since different calculator. So for Numworks, you're going to go to equations and you'll add an equation. You can use whatever letters you want. So if you want to use A, B, and C, you can. You can type in using the alpha button to access any of the letters. I'm just going to use X, Y, and Z because it has these pre-made templates that just save us from having to type in more stuff. So I'm going to use the X, Y, Z equals 0 one, and then just put in my numbers in front. So first it's going to be 1, 1, 1, 32. Add an equation. I'm going to again pick that template. And now we've got 9, 3, 1, 37. And then I'm going to backspace just, oh no, we're okay. Okay, that space made me nervous, but I think we'll be okay. And then one more equation. Use that template. 25, 5, 1 equals 29. And then I'll hit enter, solve the system, and it's again giving me the exact same values. So equation solver in Numworks, PolySmlt in all of these. We're not actually done yet here. We want to find it, or I guess we are kind of done A, B, and C. I'm going to write out the equation though, because we're going to need to use that for the next parts. So the equation h of t is going to be a, so I don't need to write any more. I can write negative 13 over 8 t squared plus 9t plus 197 over 8. Hence, find when the height of the object is 0. So now, to do that, we're just going to need to figure out, okay, when is the height 0? It's some form of parabola that has at least 1 0. It's a falling object, so probably we won't care about the negative one. We want to find that value. So let's go on over to graph it. We'll type in our equation, negative 13 over 8 t squared, so using x, plus 9x, plus 1. I like using parentheses around fractions just to make sure it knows it's a fraction. Just using x. Numworks also just use x whenever we're graphing. So let's hit graph, and no clue if my window will be appropriate. It looks not too bad. So I could just go ahead and solve it here. I'm eventually going to need to find the maximum, so I'm just going to adjust my window so it goes maybe y max of 100 feels good enough based on what I saw. We'll see. There we go. Okay. So find when the height of the object is 0. So I want to solve the equation. 0 equals negative 13 over 8t squared plus 9t plus 197 over 8. Second trace 0. Left bound right here. Right bound is here. And my 0 is 7.54. So t equals 7.55 seconds. I know I don't need this one because I was told it's the height of a falling object, so it doesn't start before the time is 0. Right, and a good way to show our work is also to label this point 7.550. So this equation and this sketch, that's what showing your work looks like here. Find the maximum height, second trace maximum. We'll go left bound to the left of it, right bound to the right, and guess we can just hit enter through that. And there we go. So the maximum height we have, I'm going to sketch out the point. That point is 2.78, 37.1, and so the max height is just the y value there, 37.1, and then we're working with meters, it tells us way up there, so meters. All right, so that is how we use either PolySmlt or equation solver. We'll see another example in the back, but this problem is one where we're given 3 points and asked to find a quadratic equation. Another way we could do that would be to use quadratic regression in our calculator, which we have some notes down here how to use quadreg in either Numworks or TI. So I'll go through how you would do that too. What this will allow us to do is it'll allow us to basically skip to this step here. While that would get you the equation you need to do part D and E, it would not get you credit for A and B if you were to do this on a test. Sometimes you wouldn't be asked to show this work, so it's enough to know how do I build a quadratic equation from 3 points. But if you were asked this exact set of questions, you would need to show all this work for full credit and do parts A, B, and C. But worst case scenario, even if you couldn't do part A and B, if you knew how can I build a quadratic from 3 points, that can at least get you full credit on D and E because you'd have the correct equations. So the way we do that in a TI is we'll go on into stat edit and we will enter our 3 points. So 1, 32, 3, or I'll just enter all three, 135, stat edit, and 32, 37, 29. So we have our 3 points, and then very similar steps to how we do linear regression. We'll go to stat, calc, quadreg, and list 1, list 2, and calculate, and it gives us this equation. These are the exact same values as this, it's just that here they're in decimals instead. And we'd substitute A in for A, B in for B, and C in for C, and we'd have a quadratic. So if we didn't need to show our work on that one, we just needed to find a matching quadratic. Quadreg is the way to go for that. In Numworks, it's going to be similar also to how you do linear regression. We'll go to the regression app. We will delete any of the data we've got in there now. So X1, we have 1, 3, 5. Y1, 32, 37, 29. We can go on over to our graph, and then we see our 3 points plotted, but we're going to go over to regression and quadratic. And we can then see our equation right here. Negative 1.65 x squared plus 9x plus 24.6. We can also, I believe, get more information. Yeah, it will write it out nicely for us there. So that, again, if we didn't need our show work, we just need an equation. Quadratic regression is another time that works. Okay, one more example problem for us. This, again, is just the instructions for how to use PolySmlt. I think there's a little typo here. I think this should just say C. Basically, this side of the equation needs to be numbers only, no variables. Like here it's D because it's a number, no variable. But that's just a summary of the steps we took. In Numworks, you also have a summary of the steps that we took to solve the system of equations. Okay, here we are going to write and solve the system of equations that represents this situation. So we are going to the movies with a group of friends. 3 of you purchase all the snacks and tickets. So Camila buys 3 tickets, 4 tubs of popcorn, 2 drinks, spends this much. We've got Juan buys 1 ticket, 2 popcorns, 3 drinks. Got the total, and Jess buys 2 tickets and a drink, and they spend 22. Okay, I'm going to use the variables t, p, and d because we've got tickets, popcorn, and drinks here. So this first equation, we'll kind of translate these words into an equation. So 3 tickets, so 3t, plus 4 tubs of popcorn, 4p, plus 2d equals $60.50. Movies are so expensive. Okay. Next, we've got 1 ticket, so 1t, 2p, and 3d equals $36. And lastly, we have 2t plus, I'm going to just say 0p, so then we'll know what to put when we go into our solver apps. So 0p and 1d equals 22. All right, so now we just need to solve this app, or solve this system using our PolySmlt app or equation solver. I recommend you pausing and trying to do it yourself, and then going back and seeing if you need to walk through the steps again. But I will do this one on Numworks first. So if we go in to equations, I'm going to clear all this, clear, add an equation. I'll just show how we can type them in from scratch on this one. Again, I think it's quicker to use X, Y, and Z, so you just have to input the numbers. But to start from scratch here, 3t, so 3 and then alpha t, plus 4 and then alpha p. Where's p? P. There we go. Plus 2d. Let's see. Alpha d. And then equals, we're going to do shift pi to get equals. So shift pi equals 60.50. I might try, what happens if I copy, nah. I was trying to be lazy and use copy paste. There's probably a way, but I do not know. So we'll just keep it rolling here. So 1t, so 1 alpha t plus 2 alpha p plus 3 alpha d equals shift pi 36. And then lastly, 2 alpha t. Here, I don't need to write 0p. I can just do plus 1 alpha d. It won't get mad at us. These equations can be in any format we want for Numworks. So now we want to solve the system, and we get, I wonder. Oh, okay. I had a moment where I was like, I don't know if this makes sense, because should we have a fraction for p? And then I remembered p right here, that's going to be the price of each of these things. So having the price be a decimal, that is totally okay. So here we've got d equals 5, p equals 6.25. I'll write it in decimals here since it's money, and t equals 8.5. So these are all of our prices here. Okay. And in TI, we'll again go second apps. So let me clear out of all this. So apps, not second apps, just plain old apps. Find PolySmlt. We have simultaneous equation solver, 3 variables, 3 unknowns, hit next. It's going to save whatever we had before, so we'll just type over it. So 3, 4, 2, 60.50, 1, 2, 3, 36. and 2, it's very important that we put 0 here, 2, 0, 1, 22, and solve. And it gets us to I have a feeling I mistyped something. Let's go back. If we go back here to system, let's see, what did I do? 3, 4, 2, 60.5. 1, 2, 3, 36. 2, 0, 1. Oh, I wrote 29. There we go. I might have forgotten to press enter. If I just hit 22 and then do solve, it won't save it. So make sure you hit enter before you solve. And now, what? Did I still? Or no, okay, we're good. It just did it in a different order. It's telling us t equals 17 over 2. P equals 25 over 4. And D equals 5, which I would recommend, since we're dealing in money here, putting those into decimals. So 17 over 2, yep, that gets us to $8.5 or $8.50. 25 over 4 gets us to $6.25, and this is just $5. So in terms of the ordering for TI, it's always going to be whatever order you put these in. So it's going to give you T, P, and D in that order. It looks like Numworks, if you use the letters, it'll give it to you in alphabetical order. If you use X, Y, and Z, it would be in the order that is both alphabetical and what you put it in. And then just one last look for if you have a newer calculator, it will be apps, PolySmlt, simultaneous equation solver, 3 variables, 3 unknowns, and you'll just have 3, 4, 2, 60.5, 1, 2, 3, 36, and 2, 0, and 1, 22. And hit enter before we solve, so it makes sure to save that last variable. Let me just double check. 3, 4, 2, 60.5, 1, 2, 3, 36, 2, 0, 1, 22. All right, and solve. There we go. Same things as here. All right, that is all we've got for today. So see you all later. Okay.